I decided that the best thing to do was to find out what the truth of the matter was. And that made a very good PhD project. And along the way, you know, we started discovering things. And I discovered what fun it was when you were the very first person in the whole world to understand something for the first time. And I think once, I call this in students of tasting blood. I think once you had a taste of a real discovery, it's pretty addictive, actually.
And then, so in the last 2 days, you've given 2 lectures lasting about an hour in which you've described broadly what you discovered. Now, can you summarize in 2 minutes yes, what it is you discovered for the audience?
So what I discovered was something which at the time was considered to be impossible. And let me tell you, if you want to win a Nobel Prize, the best thing to do is to do something impossible. Right? So what I discovered was that there was 1 or 2 proteins inside developing eggs of clams and sea urchins which disappeared each and every time the cells divided. And it was also known that you needed to make new proteins in order for the cells to divide. So a simple-minded explanation was that you needed to make this protein, and that catalyzed cell division. But then to complete cell division, amazingly, you had to get rid of it. Because otherwise you'd be stuck in this sort of tensed up, dividing state. And that's what happened. I mean, I saw it with my own eyes. I mean, there's no question about what happened. It raised all sorts of questions because nobody could conceive of them, and I couldn't. I had no idea what the mechanism of destruction was because this protein was completely stable until the cells started to divide. And then it became incredibly unstable. And then once that was over, it became completely stable again. So, whoa. I mean, it took years. It took 25 years before we understood that control mechanism. I made no contributions to that whatsoever. But what I did was to just say, this is a very interesting protein and its behavior is extremely suggestive. Let's just find out what it is and what it does. And when I did find out what it is and what it does, it turned out to be, as the Nobel Committee said, a key regulator of the cell division cycle. So it was, I right from the start, I knew I'd stumbled on something very, very important and very, very interesting. And I must emphasize that it was a completely accidental discovery. I mean, the experiment that revealed it was designed to test something completely different. So it was absolutely 100% accidental discovery, which anybody could have made in the preceding 10 years.
Except as Pasteur says, chance favors the prepared mind.
Well, I suppose, yeah.
So, okay. So we'll come back to you in a second, Tim. Thank you very much indeed. I know that discovery and the explosion of interest in the cell cycle that it generated has turned out to be very important for your work, Dr. Noreen. So you're a young researcher, and congratulations, by the way, on the award of your PhD.
Thank you.
In what way has Tim's discovery and the explosion of interest in the cell cycle influenced your research in cancer?
Right. Breast cancer, cancer, particularly breast cancer, has always been my research interest all this time. And the fact that Tim discovered this cycline protein, it is a very, very important regulatory protein, as you mentioned just now, in cell division. So just now, in the morning session, when we were preparing for this forum, a few persons in this hall was asking, they were asking, what is cycline? What is cycline? Obviously, because they're not from the science background. So what I'm trying to tell now is what is cycline and why is cycline discovery by Tim is very, very important in the cancer research. So, you know, when after fertilization, cell will divide, okay, from single cell to 2 cells and then 4 cells and exponentially, and creating a living organism. So cell division is very important, not only to develop into a living organism, but it also helps to maintain the living organism by helping with the tissue damage repair. So because cell division is very, very important for the living organism development and also maintenance, it has to be a mechanism on how you can really control this process so that it, both spatially and temporally, so that the living organism is is in a balanced state. There's no cell over proliferating, and there's no less proliferating cells. So, and this cell division is controlled by cell cycle, and cycle has to be very efficient. So this cell cycle is regulated by cycline, as what Tim discovered, and also with the CDK protein. Together, cycline and CDK protein will make a cycline-CDK complex. These are the regulatory subunits within the cell cycle that make sure that the cycle is moving in the right direction. So cell cycle has 4 phases, and each phase has different cycline-CDK complex subunits that control so that the cell cycles proceeds in a good way. And whenever there's a mutation, for example, during DNA replication, and then the cycline-CDK complex will send a signal, okay, hang on, there's a mutation going on. We have to fix this mutation first before we can actually move on to the next stage. So this is what cycline-CDK complex does. So in cancer states, right, we know that cancer cells grow indefinitely. This is because the regulatory mechanism has gone haywire, and partly is caused by the cycline-CDK complex going haywire, being malfunction. So the discovery of cycline, and later on with CDK protein making complex, so leads to the understanding on how cell cycle is being regulated and what is going on, what is going wrong that has caused cancer. So that's why Tim's discovery is very, very crucial in revolutionize the understanding of cancer pathogenesis.
Thank you. And are there already drugs coming through the pipeline that affect the cyclin CDK complex?
Yes. We have now a few FDA-approved CDK inhibitors, as far as I'm concerned, for breast cancer, and there are also CDK inhibitors in the pipeline under clinical trials. So that's why it is a super important discovery.
Are you involved in that at all?
Unfortunately, I wish I could involve in this research niche, but mine is more on bone metastasis. So,
oh, that's interesting question. Yeah.
Yes.
Okay.
Thank you very much. Okay, so thank you very much, Dr. Narayan. Now we're here to talk about how best to nurture this generation of scientists, and we note the comments in the introduction about the worrying trend in the number of young people in Malaysia. And it's not exclusive to Malaysia, it's a worldwide trend in many places. The worrying trend that people are not going into science at school as much as they used to. Professor Fuad, would you like to summarize for us the situation, or say a little bit more about the situation regarding STEM in Malaysia?
Yeah, of course. Thank you very much. At least I've been given the responsibility to take you from the molecular world to a bigger picture of what's happening. Right? In Malaysia, we identified is, in the early part of the millennium, that interest in science has been decreasing. Now, what really happened was that in 2018 or 2019, the scientific community, together with the government, realized that we have so few students in the lower secondary, just like the UK, when you're 15 years old, we say they are in Form 3.
Sure.
And then after that, they either go to science or the upper secondary, right, when they are 16. But less than 20% decided to go into science.
Wow.
Now, what happened after that was the pandemic.
Immediately, just doing.
Now,
We were struck dead.
They don't have any labs. They learn at home, and suddenly we found that the latest statistic shows that only 40% of a total of a few hundred thousand sitting for our last time was called Senior Cambridge, Form 5, at the age of 17, less than 40% going for science. And even then, after that, even less going into STEM. Be they, how do I say, vocational or technical or TVET, right? So we find that, yeah, what is it? Thank you very much. Yeah. Okay. Yeah, hopefully I don't need to repeat. Well, I can't remember what I said just now.
Carry on.
Okay. You are from the same generation almost.
Yes, exactly.
Now, where was I?
We've talked about the lack of numbers of people going into science.
Right. Now, after the pandemic, we realized that if we don't address this situation, Malaysia is going to have a problem. Because the world, the WFT, was it? The World Trade, the WTF, was it? Every year they
World
come up
Trade
with
Forum, yes.
the world, what call that? I forgot. World Economic Forum.
Oh, yes.
Every year they will come
Davos
up.
people.
And by 2025, 9 out of 10 job opportunities will be science-based. Meaning to say, if Malaysia do not address this situation, we are going to be very far lag behind. So maybe what we can learn, what can we learn from
But
yourself?
just before we talk about what we can do about it, Tim's question, why has there been this fall off? Do you know? Any clues as to why people are not taking science?
Yeah, whatever I'm going to say, I don't have any study on that, but it's more personal.
I mean, are they scared or bored or what?
That's what they are saying, that maybe when they talk about science, they get sort of put off because they need to memorize a lot.
Yeah.
To learn formulas, things like that.
Yeah, I think that's
Yeah.
a big problem, actually. I was horrified when my younger daughter
Oh,
was doing a biology homework, and I looked at her book, and she had to memorize the 6 facts about fir trees which adapted them to cold. And I looked at these 6 facts, and they were sort of random. They didn't make much sense to me, and there was no explanation of why the. So it just instead of trying to understand, it became a pure learning exercise. It was just a memory test, you know, and on the assumption that if you were good at memorizing things, it was probably helpful for your future life. I mean, that's not a reason for doing science. And if I tried to explain to her, you know, oh, Dad, shut up, just tell me what the answer is.
Yeah, exactly. Yeah.
are we having the same problem over there in Europe or UK?
Yes, I think so, broadly. I mean, it's not so overt. I suppose the job opportunities for those trained in science are very obvious, and therefore that attracts large numbers of people to take it because they think about their futures. But certainly I've heard the same thing a lot in Asian countries. We were in Korea in September, and they were saying exactly the same thing. So I think, it is a worldwide phenomenon.
And don't forget what we heard at lunchtime, which was that learning the cell cycle.
Sorry, learning about your work in particular.
Yes, was really tedious and the worst thing they had to do because it was reduced to a series of things you had to remember.
Yes.
And with absolutely no, it's just too complicated for the poor human brain to comprehend.
But is it also a worry about salaries, Professor Fouad? I mean, are people thinking about how they can get the best salary and it's better to go into business than science, or what?
What we found out is that you earn a lot of money by not doing science. Yeah.
Accountancy.
I can tell you what. I tell you what. The pandemic, right? It leads to a lot of job losses and things like that. And somehow or other, they found that, well, if they become you can just dial and then they go and take the motorcycle and send the food. It's, what do you call that? hailing, e-hailing or whatever.
All right, okay.
Right? They will just call and you take your motorbike, just send, you get money,
I see. Yeah. So-
easy money. Then sometimes they say, if I become an influencer in YouTube, that will be fine. For instance, I'm talking about our generation. Take an Engelbert Humperdinck song, put them together, you get 1 million, 2 million, 3 million. How to say listeners, you get the money. So those sort of things. But
So, Dr. Narain, do you not care about money then? Because you're going into science.
Well, I'm not good as a social media influencer, and I'm more passionate into teaching and research. So, based on your opinion, Tim, based on your experience, how do you think we can help the young generation to, nurture interest into science, or better still, STEM, the science, technology, engineering, and math subject fields?
Yeah, I do. The answer is I don't know. Short answer. Because the kind of things that inspired me, as I said, were these sort of natural things. Like, I learned that if you mixed fertilizer with sugar, you could make an explosive. And then I learned how you triggered that explosion with a simple transformer that provided current for my electric train set and a bit of wire wool, stuff like that, simple things. And I say taking radio sets apart was very informative, but the trouble is now, you look at a mobile phone, it's a marvel of technology, but you can't take it apart. And even if you could take it apart, what would you find inside? Just a piece of plastic. It would be incomprehensible. So, I don't know. I think what inspired me was practical doing things, melting things, boiling things, exploding things. And certainly I was much better at practical things in the lab, and that's how I learned things too, because from actually my own experience. So, and I was hopeless at learning things, and I was useless at maths too. The only exam I ever failed was a maths exam. And, so, whereas my physical science colleagues tell me that maths is the basis of absolutely everything. They emphasize how important maths is. I don't think it's
Everybody goes on about how important maths is.
Yeah, I don't think it
nowadays.
is. It's absolutely unimportant. No, that's not true. It's not a thing I should boast about.
No, but our Prime Minister in the UK now says that everybody should learn maths until they're 18.
No, I think that's crap.
Yeah.
If I may intervene. Tim, from your stories, right, that you like to pull things apart,
Yeah,
and you
yeah.
explore so many things, making things explode and things like that. It seems to me that you are so explorative, very curious, and even I read a couple of your papers, like the one that you published back in 1983, and another one was, I think, 1989, something like that, on cycline and the maturation promoting factor. And you have so many open-ended statements and questions. And the feeling that I got when reading your papers is the curiosity is very, very high. So I think this is how, because of the curiosity that leads you to getting the Nobel Prize, right? So I'm just wondering whether the young generation now lacks this curiosity and inquisitive mind.
Yeah, but I don't know how you foster curiosity. It seems to me it's one of those things either you've got or you haven't got.
But everybody young has it. All the little kids have it.
Yeah.
So is it the school system which knocks
Well,
it out
I think
of
it does knock it out of you because it sort of forces you into the straitjacket. I was appalled when I discovered, again, in my children's education, I was rather excited because my elder daughter was learning about the Romans in Britain. And then my enthusiasm was rather tempered by discovering that every other single child in the United Kingdom that was aged 6 was learning about the Romans in Britain that week. We have a national curriculum. You must know this, that. This is rubbish too. We're all different. We all need to know different things. So the school system, I think, has a lot to blame, and it's all this sort of measurement that you have to be assessing everybody all the time and know exactly where you are and put a number on it. I'm number one, you're only number two, so I'm obviously deserving a larger salary. You know, it's horrible.
It's also the case that, I mean, the whole system, and it's very hard to understand how to think about how one would change it, is designed on people passing particular benchmarks at particular ages. And you so that you make a decision, as you said, Professor Fuad, at the age of 15 or so, what you're going to do when you're in 16 and 17.
Yeah.
It's quite hard to change your mind, possibly impossible to change your mind when you get to 17 and say, I wanted to do science. Is it too late? I mean, we have it's a very strict
No, it's
way.
never too late.
Never
actually.
too
That's
late.
Really interesting. This guy, what's he called? Tony something, a Nobel laureate. He read classics at Oxford
Oh yes,
and
right.
then switched into quantum mechanics.
That's is that yeah? I don't I can't think. But Harold Varmus, of course, read English at
Read
Harvard,
English,
and,
yes,
and then
a
became
biologist. So actually, I mean, I think I wish I could remember his last name. It'll come back to me. Tony, I was sitting next to him at dinner in Singapore, and he told me this amazing story. I mean, he read greats in Oxford. That's classical literature, philosophy. And he thought, I'd quite like to be a philosopher. But then he thought about it a bit more. He said, well, I don't really want to be a philosopher because in philosophy, you really can't tell whether you're right or wrong. And he'd done a bit of maths at school. And he thought, I don't want to do maths because if you're wrong, it means you're stupid. And he wanted a field where he could be wrong, but in an interesting and constructive way. So he thought physics was it. And he was enabled to switch to physics because at that moment, the Russians launched Sputnik. And suddenly Britain thought it needed many more physicists. So he was able to get a grant to switch into physics. And he turned out to be a brilliant physicist with no scientific education whatsoever before the age of 22 or 3. Amazing, absolutely amazing. Now, he's a smart fellow, of course.
What we are trying to do over here in Malaysia is that we are going to go for experiential learning, right? Let's say we're trying to find ways. We call that in our terms APEL A, APEL C, APEL Q, whatever acronyms that we're giving. Meaning, if let's say you have done something like you open up a workshop, right? You're an apprentice there.
Yeah.
You have never gone into college, but you know how to open up an engine and put it back.
Yeah.
By listening to the engine, you know what's wrong. So we are trying to find ways whereby this working experience, can be changed into something that he can enter college.
Yeah,
That's a good
I like the idea of that very much.
No, it's not my
actually.
idea. What I mean is the government idea. I'm just trying to say what we
Because
are
I think
trying
it's the
to-
doing of things
Yes, we
that
are trying
really
to do that.
stimulates the thinking about them, actually.
But hopefully you are going through the right track.
Yeah.
Okay, but there's one thing. I've got to, you don't mind, yeah?
No.
Actually, there's a plot twist here. We were supposed to be the moderators, right? But our good friend here turned it to be, a panelist. But I still want to ask something.
Okay.
May I? Okay.
Well, no. You can't.
Yes. It's not really a question. What I'm trying to ask is science killing science? Okay, I tell you what. I've been to a conference. There's this computer researcher talking about in front of the young, audience about machine learning. So happy about machine learning, deep learning, not knowing that he's talking to humans. So are we by having all these technological advancement, that we are creating something that, let's take the easy way out. Somebody is doing this for us, just pick a button, you got the answer.
Yeah, I think you're sort of talking about laziness, actually.
Yeah, I don't know. Yeah.
Because, but I mean, if you actually ask ChatGPT about something,
yes.
hopeless answers, in my opinion.
Yeah.
I mean, nothing ever original, always very anodyne, because it's only based on past experience. It
but
can
that
never
is-
make a discovery.
That is where we are headed.
No.
No,
Don't
what I'm
worry.
trying to say is,
No, don't worry.
what I'm trying to say
And
is,
have you ever tried
do we
to
stop
hire-
that? How do we stop that?
Well, I mean, I tell you one thing that that's really interesting. Recently, a lot of things have gone wrong in my house, right? The heating, the hot water
All right,
stopped.
okay.
So you have to call a plumber, right? Now, some of these plumbing companies have these chat bots. You can't actually talk to a human being and say, can you send a plumber? You have to interact with a chat bot.
Yeah.
Useless, never results in anything. But get to a human being, and I think something went wrong with my phone, and I just had to sort of call up. And the minute I got a human being, boing, problem solved. But the chat bots never solve anything for me. Maybe I'm just antique and
Yeah.
I don't ask the
Yeah.
chat bot the right questions.
No, that's one thing. We over here, we are young lecturers. We are going to train future scientists, right? So what do you see them using ChatGPT for proposal? How do we go there from there?
Well, I don't think they'd be very good proposals.
It's super. The English perfect.
Well, the English would be perfect. Well, that would be okay, you know, but actually, I really don't believe in all this AI nonsense because it's entirely based on data whose integrity you don't really even understand.
Now, we have an issue here. Both of us, we come from a different generation.
This is true.
So how do you think about that?
Well, I know Nobel laureates who have very different views on this and think that we have to embrace it all and that it's going to be a very helpful part. But one thing that I think is perhaps missing in education, in perhaps the way that people are practicing science, especially if they're relying on machine intelligence, and perhaps missing from this discussion so far, is the word play. It strikes me that Tim, as a child, nurtured his interest in science through play, pulling things apart. Certainly, the way he approaches his experimentation now approaches play, or did when he was in the lab. It's trying to discover things, it's trying experiments. Play is such an important part of this, and I don't suppose that young scientists, the people in school, associate the word play with what they're doing. If they're doing physics, chemistry, or biology, I don't think the word play comes into it. They never get encouraged to play.
No.
But surely that's missing something, because that's what attracts him and many Nobel laureates to the art of science.
Yeah, I mean, I remember a lesson, the interesting biology lessons that I recall from my youth were, my baby brother's rabbit dies. So what do? Take it into school and dissect it. This was really thrilling, you know. We'd only worked on horrible pickled dogfish up to then, which were kind of horrible dirty brown color, and you couldn't tell anything when you had to dissect the 9th cranial nerve, which was, actually quite good in later life, because I'm quite good at dissecting fish now. For when they're presented in the restaurant as a result of that, but that's by the by. But, we would go out into the school field and we'd ask, why are the nettles growing there and not there? Simple things, but mysterious things, which demand an answer, asking questions.
And importantly, don't always have an answer.
And may not have an answer.
Because everything you learn in school has an answer, and that's pretty depressing, that you either know it or you don't.
I love to tell the story of my daughter Celia's bedtime question. So I'd just been made a Nobel laureate, so I could walk on water and be in 2 places at once. And she said, "Daddy, why is the ceiling opaque?" So I looked at the ceiling, and indeed light did not get through the ceiling. And then there was still a little bit of light coming through our window. And I suddenly, oh my God, I'd been reading Einstein's paper on photons. I said, how do photons get through glass? Are the little holes in the glass that they get through? And I realized we'd done all these experiments at school measuring the refractive index of glass, but nobody had ever said, why is the glass transparent? And it turned out, I spent about 7 years investigating this question. It takes you deep into quantum physics. And actually, nobody can really explain why glass is transparent and the ceiling is not. But I think that's an amazingly important question, and the kind of question that they should be asking in schools, and rather than saying, yeah, here's the equation that explains it, you know, really try and imagine what it's like to be a photon hitting the glass. And
I would like to take the positive from this. Okay, never mind. Maybe she needs something.
Well, if you had you're
Yeah,
allowed a
I
quick
need to say
summary,
something
but-
positive. Play is a big thing.
Yes.
So as the dean of the faculty, let's play more and get the Nobel laureate.
Good idea.
but what's the
Rain,
difference
you're-
between
you're-
playing and fooling around?
Dr. Rain, you're a lot closer to the generation we're talking about.
Well, I'm still in generation Y, and the current generation that we have now, that we are trying to nurture the scientists, the interest in science is the generation X, right? To me, I still I'm a very conservative person. I'm still believing in teaching has to be face to face, whereas in this digital era now, we have moved from the solely face to face teaching into online learning. I mean, I agree with the online learning, given that they are combination between online learning and face to face. But if you have so much online learning, I think this is one of the reasons why. Because they don't have the face-to-face communication, because they don't get to play the objects. They only look at the screen and by learning facts and things like that. So
It's not the same.
that's
is it?
because that's why they don't have the explorative mind, the inquisitive mind. I think if you can have a balance between online learning, and I would agree more on face-to-face learning, then that will probably help to overcome this problem. So
I think absolutely.
Yeah, I mean, it's sort of interesting. What you just said made me think of those. You know, I often look up recipes online, and some of the best things are little movies where people show you how to make noodles or whatever it may be. But always it's a bit of a fake, because usually, you know, you have to wait for them to boil for 5 minutes or 10 minutes or something like that. So that, of course, never happens in the movie. Now I boil them for 10 minutes, but actually, boom, here they are. You know, so that's the trouble with online stuff. It's mostly not quite in real time or in real space, and you need to know when you have to boil things for 3 hours, or when it's okay that they only take 2 seconds, and that's something you can only learn by watching somebody actually do it.
We've discussed a lot already. There's lots more to discuss, but I would really like to know if there are any comments or questions from anyone in the audience. Please, it would be lovely to hear. So don't be shy.
Yeah, if we have a solution.
Yes, if maybe somebody wants to add to what has been said, or just to ask a question. It's fine to ask Tim what it's like to be a Nobel laureate. That's okay. But whatever you want. Does anybody want to? Somebody needs to be bold and ask the first question. Okay, there's one at the back, and there's also. We'll go to the back first, and then I'll come to you. Yeah. Please, if you could stand up, it would help.
Yeah.
Thank you.
Thank you, sir, for the lecture that you are giving this panel discussion. So, sir, I have a question, like how we are going to convince our new generation and our scientists or researchers to work more on science and technology. If they see like the food vlogger, the influencer, and the motivational speaker, they are earning more than us. Like just making one video on TikTok, they are earning a lot, like 10,000. And the researcher here in like 10,000 ringgits, and the researcher, PhD and master researcher, they are just getting 2,000 or 2,500 ringgits by spending 9 to 10. And plus they get the comments from their supervisor. In 3 years, you have to publish 3 Q1 papers. I don't know what it is about. I just need 3 papers. So how we are going to convince that?
That's a question that comes from the heart. So the salary point is one for the politicians, and we don't have one here, but maybe the dean can set salaries, I don't know. The question about publications is a very important one, the driving force for publications. Does anybody want to take up any of those points?
I think on the team.
Well, on the money question, it amazes me now in retrospect how utterly confident I was that somehow I would be okay money-wise. But money was never any motivation for me whatsoever. And I've been rich and I've been poor. And richer is better. There's no doubt about it. Because, basically winning the Nobel Prize was 4 years tax-free take-home salary. It makes a big, big difference, that. So from having always to worry about money, I went in just a twinkling of an eye to not having to worry about money. And that's a much more satisfactory state of affairs.
On the publication question, do you have any comment? Because the drive for publication is a problem everywhere we go. It's talked about among every audience we meet.
Well, if the problem is, if you're a scientist, you're being paid to find things out. So, the more you find out, the better you are. So how do we know how much you're finding out? The answer is, you tell the world what you found. And then the question is, what do you mean, tell the world? And the problem is now that people can tell how many people, it's like the influencer thing, how many Twitter followers or whatever do you have? You can sort of measure that. But, that doesn't mean just because you only have few followers means that maybe you're in a very specialist field. And it's sort of not fair. So we haven't really resolved that one. And I think it's a very difficult question. And I think it's worse now because we're more into these metrics. It's sort of, metrics are horrible, but I'm afraid necessary.
Dr. Narain, do you have you must be feeling this pressure. Do you have a comment on it?
I think if you have interesting finding from your research, of course you want to share it with the community,
exactly.
right? So to me, there is no pressure. If you feel, I know it's a pressure when you're a student, right? In order for you to pass, you have to publish 3 papers. But
Is that a fact? In order,
we have this.
No, that's
like
true.
2 or 3
We didn't
papers.
have to publish anything. We did, though, I must say. I think I published more than 3 papers.
Okay.
But it was no requirement.
Yeah. So
My great friend and elder and better and much smarter scientist than me published no papers. So, and got a big fat PhD out of it. So I think it's really silly to set paper,
a number. Yeah.
the number. It's really,
I think
you shouldn't do that.
You understand?
I know. What I'm trying to say is, think of it on a different perspective. You have a good research data that you want to share with the community, and just trying to get as good paper as you can, and then that's fulfill the criteria for you to pass your PhD, for example.
Thank you, Prof. Phil.
Over here we have what you call KPIs, key
Yes.
performance indicators, and publication is one of them. Like it or not, you need to publish. Personally, I have a rather different point of view, because whenever or whatever that you publish, the things that is going to be read from your publication is by a small community.
Yeah.
A small community.
Maybe a tiny community.
Thank you very much. Tiny, a minute community, right? But then, since for Malaysia we are developing, and we need to publish. But I have how do I say, a rule as the dean that for me, you don't press your students to publish more than what is needed. For instance, in Malaysia, let's say for a master's or PhD, you need to only publish 3 papers, right? I would tell my fellow lecturers that if your students has published 3 papers, enough. Don't ask them to publish more, right? While they are under your supervision. After that, they can continue to publish. what I'm trying to say is I'll try to take the stress off the postgraduate student.
Sure, but that three paper
I think that's a pretty heavy
requirement,
load. Or
it's a heavy load. Yeah, it's unusual, and I mean for other countries. And
Yeah.
you look at it
I
is
can
argu-
see sort of one paper would be.
yeah, it is arguable that one
necessary.
important paper could trumps three.
Of course. I graduated from UK also. I didn't publish any papers and got my PhD.
Yeah,
But
exactly.
I cannot impose that in Malaysia. We have a different standard.
Yeah.
But I would
That's the
like to
rules.
not go overboard.
Yeah, no, I understand.
sure.
Yeah.
Another comment, yes, please. Can we have the microphone at the front?
Okay, thank you. First of all, I would like to tell the team that in UniKL, we don't put that is a requirement for them to publish 2 or 3 papers for them to complete their PhDs. I have insist that is not the requirement here. Maybe the other universities in Malaysia, because for me, I don't believe that the students need to publish. But sometimes the pressure is on the students. They want to publish.
feel it.
They feel like they want to publish so that to make their thesis stronger. But in these universities, it's not a requirement for them to publish. They don't have to publish for them to submit their thesis and to have a viva whatsoever. Okay, so that is something that I would like to clarify. Another thing is I just want to have, I have 2 questions basically. I have attended one event when I was in UK, when I was in Glasgow, talks by members of those people that work with for Dolly the ship.
Yeah. Dolly.
Oh, Dolly.
Dolly the
yeah,
Sheep,
yeah,
yeah.
yeah, yeah.
They
Transgenic.
they spoke that okay, for you to be able to get the Nobel laureate, one thing is you must be good, but there are 2 other elements that they said is the place and the time. You must be at the right place and the right time. Does it very important to have the right place and the right time? For example, let's say Malaysia, we have not have a Nobel laureate yet. How can we create this kind of the other 2 elements so that in future Malaysia can have their own Nobel laureate that we can be proud of? So this is the 2 questions.
Yeah, well, I think, I grew up in Cambridge, scientifically speaking. And this, as I was explaining to the audience on this morning, I mean, it just had a fantastic tradition of really amazing discoveries. The whole structure of the atom was worked out in one little lab in Cambridge by generation after generation. Now, how do you explain that? Is it something in the water? Is it the cake they eat on the way to work? And it's very hard to, it's hard to say, but it's undeniable that there are certain places where somehow this tradition of learning, understanding, investigating really fundamental problems seem to be fostered. And if you haven't been shown that, I think, and I think it is a matter of being shown it really, rather than saying it. There's something, you actually have to work alongside people to see what it's like, to see how their minds work, to see what they do and how they react to different situations.
So is the answer to the question of how do you position Malaysian scientists to be in the right place at the right time, that you should have more exchange, you need to have more people that move around, experience other situations and then come back and then try and set up institutes that...
Yeah, I
replicate?
think that's pretty good actually. Watch how it's done and take that example. But I mean, of course, that's not the whole. I mean, look at Bell Labs, for example. They just assembled an incredibly talented team of scientists and allowed them to do whatever they liked. And they invented all kinds of amazing things there, and then the labs were dispersed, and they don't do that anymore, which is a shame.
But that's such an important point, that allowing them to do whatever they like, because they trusted the scientists to make the right decisions at Bell Labs.
They didn't impose, you've got to invent the transistor, because of course nobody conceived of the transistor, and that's the thing. I mean, the real discovery, it's so important to emphasize that, we do not know what we don't know. and we're terribly prejudiced. We sort of think we understand things pretty well, but actually just looking at the recent past tells you you don't. You know, constantly new things are being found out and your old ideas are being overthrown.
Can I add something from our Prof. Bushari's question? All through these years, the Nobel Prize winners, they have done a lot on fundamentals, right? I read once Watson and Crick, right? They found that double helix. When he was interviewed, right? He said, well, maybe there will be a medical application in the future. That's it. Just like what you found.
Yeah.
You found cyclines, and maybe somebody else will do that. But it seems that the fundamentals, right? Is it true that if we go to the fundamentals, we would stand a better chance for a Nobel laureate from Malaysia?
Well, yeah, I mean, that's how you win Nobel Prizes. You find out things that nobody even imagined, right?
Yes.
Or better still, people found out things that people said was impossible. Like Fred Sanger won his second Nobel Prize for sequencing DNA, which my teachers assured me was theoretically impossible. You know, so you do something that's theoretically impossible, you might win a Nobel Prize.
We have another question here, please. Microphone. Oh, you have. Could we get the mic?
Can you introduce yourself, please?
I'm Azman from Sirim. I was a researcher lecturer in university for 15 years, and now I came to Industrial Research Institute. Now, Prof, Sir Tim, regarding continue from what Prof Fuad said just now, regarding the fundamental aspect of research that we should focus to get a Nobel laureate. But now we have another scenario, challenges for researcher in Malaysia, where we are facing now that somehow the commercialization of products, the return of investment, when the government give money to do research and they need a return and they need us to come out with a factory company with products. Just to share with you, at moments today, the fundamental grant, when they offered, there is a needs requirement, that letter of intent from company that they are ready to do business with you. These are fundamental project.
No, this is horrible. And I've seen this actually at first hand in Singapore. And it's a very unsuccessful way of organizing research. It's not right. I mean, I'm not sure exactly why I know it's not right, but it isn't right. And it isn't the way it works. I think that what the sort of funny thing is, so in UK, we're very successful at finding out these fundamental things, but not very successful at commercializing them. In Korea, they're fabulous at commercializing everything, but not very good at the fundamentals. So I think the thing is to go to Korea and ask what they do. Because they're a wonderful example of how, you know, and you go and look at, I remember visiting Hyundai, where they just discovered how to make bigger ships much cheaper. And that company, you know, was started by a little guy mending bicycles in his garage, you know, and just by sheer sweat and intelligence. You know, you sort of need intelligence in your fingers as well as your brains, like that.
If you don't mind, I would like to continue from
Yeah,
our friend here. Now, the thing about Malaysia, or our country, I think it is not wrong for the government to see the ROI, because we need to spend money. And money don't come easy for countries like Malaysia. Now, where do you get the money from to do all this fundamental research in the UK, for instance?
Well, you see, well, the answer is actually comes from two sources, really. One is the government.
Yeah.
And the other is the charitable sector, actually, especially in medical research. There's a huge investment by the public into cancer research. Most cancer research is subsidized by public donation. Amazing. I mean, you know, it sounds...
The charitable.
And then there's the other big source of money, which is the Wellcome Trust, which was an incredibly wise investment by a very clever finance director at a certain stage in the company. And they got a huge capital, which they can spend on research. But where they spend it depends on the whim of the director.
Yeah, yeah.
And so, I mean, that's all. It was ever thus. And so if there's a minister whose ear you have, maybe he'll support your research. But I do think this business about insisting that everything being commercializable is really deadly, because it stops people actually listening to nature.
And I want to bring in, there's another question here, and then there was one here, but first over here, the man in the jacket. But I just wanted to say that, I mean, we're talking about this next generation of scientists, and you want the people who are the most curious, the most inquisitive, who want to play the most with the fundamentals of nature.
And do something different.
And do something different to join
Do something
science.
different and do something better.
Join science. But what they see ahead of them is a narrowing, that they're not allowed to do that, that they're going to be told, in the end, you can't do that, you have to be focused. And so that is perhaps a disincentive to some to move down that path if they see that far. Most people don't think that far ahead, but if they did, maybe that's what they see. So I don't know. Please.
Okay, I am Dr. Imdad of Medicine in UKL or CMP. So in Malaysia, in fact, we are desperately trying hunt a Nobel laureate, and today we have got the Sir Tim Hunt. So I believe that certainly this is a one step ahead towards achieving the target of Malaysia. So my question, going back to your discovery, the cycline, as it has got a very important or significant role in cell division, and in cancer, since there is an excessive and uncontrolled proliferation of the cells, what happens to the cycline at that time, and what is the role of the cycline, and is there any way to inhibit the cycline so that we can stop the proliferation of the cell in cancer? And another thing is, I want to finish.
Maybe
So,
let's just take that thing first, one thing at a time. So if you inhibit cell division, we know what happens. You die in about a week. It's a very unpleasant death, as the unfortunate inhabitants of Hiroshima discovered.
targeted cell division.
Yeah, but how do you target it? How do you just inhibit the cancer cells? That's the problem. If you give a drug, all the cells feel the inhibition. And there is no way of targeting those. I mean,
But there are research going on, trying to target. Maybe
yeah. Mostly unsuccessful, I must say. In fact, the best way to target a cancer is to cut it out with a knife. That works very well.
Dr. Narain, please.
Well, I read a couple of articles regarding CDK inhibitors, for example. I mean, so far they have been targeting the CDK protein, not on the cycline. I think because the cycline protein is fluctuating, there's oscillations going on with the cycline protein. So it's really, really difficult to target because you have to find the right timing to really target the cycline protein. But in contrast, the CDK protein is much more stable. It's almost there, like all the time, unlike cycline. So there were two research being going on now. One is targeting the cancer cells with CDK inhibitors, so that the tumor cells will all be synchronized, and then they will be at this. They will have cell cycle arrest at the same time, and then we stop the treatment with CDK inhibitors, and then we treat them with chemotherapy drug, for example, or radiotherapy. So then this will help to kill all the tumor cells at the same time. So this is one suggested mechanism. And the other mechanism is what they said, CDK inhibitor as a protective agent, where you inhibit all the cells in the body. So the cells will stop proliferating, and only the tumor cells will continue to proliferate. And then you use chemotherapy drug to target these cells, because chemotherapy drug only targets highly proliferating cells. So the the research is still
Okay,
going
so-
on.
so they're
And
not
I
expecting
think
to finish right
until now, only breast cancer
are, or
has
they're
been
not, or
approved.
they're
I mean,
expecting-
only the CDK inhibitors has been approved to use only on breast cancer cells, simply because the non-specific effects of CDK inhibitors is really, really difficult to target only the tumor cells. So they're trying to like combine the CDK inhibitors with chemotherapy drug, for example, and radiotherapy to make it more selective. So that's what I know from my reading.
Thank you.
Your second question.
Okay, thank you, Narayan. So the second question is, what's your suggestion or what is the message for the new generation scientists of Malaysia towards winning a Nobel Prize?
What message? What's your message for the next generation of scientists in Malaysia, with the goal of winning a Nobel Prize? And as you say, you think everybody should set out with the goal of winning a
Well,
Nobel
yeah. And you know, you just have to find out something that nobody else in the world knows. That's important.
So do you have? So what message would you like these teachers
you
to
know,
transmit to them?
Yeah, I think so, you know.
You can think about it. I can come back in 10 minutes.
No, I do think you know, it's this matter of doing rather than thinking. The thinking comes after the doing. Too many people overthink it
Yeah,
and underdo it.
yeah.
Maybe but I think the other point I should make is that, you know, it is winning Nobel Prizes really is a matter of pure luck. You do have to be in the right place at the right time and do the right experiment, and you can't predict that, because if you predicted it, you'd already know what you're trying to discover. And the whole point about discovery is you don't know. You get a shock when you discover it. Can it really? Yeah, wow. You know, that's the thing. So there are lots of different kinds of science, and there are a lot of applied science. It's really wonderful science, you know, and it requires just as much, if not more, effort than this Nobel stuff. And there's nothing wrong with it, you know, and it's very much to be encouraged. I take the view that doing basic research actually is rather good training for doing applied research, because you need exactly the same thing. And basic research is really more fun,
Right.
because you're just sort of free to do whatever you want. But, you know, not everybody is that good at it. So,
Do we have any more questions? Yes, please. Yeah. Or comments?
Hello and
Can you hold it close to your mouth? So speak up.
hello and good afternoon, Sir Tim. I'm a master's student. I'm from Pakistan. It's an honor to welcome you. My question is a rather simple one. My question is that do scientific discoveries and being curious go hand in hand? Is being curious a synonym for being a scientist? Because I've seen in movies that the scientists do cool things, and they are always wearing their medical coats and, you know, doing cool sort of stuff. So, or is being a scientist a mundane job? Nothing rather interesting.
I love that. Is being a scientist cool, or is being a scientist mundane? I think that's a good...
well, you know, it's a funny mixture of both, actually. And I never ever wore a white coat because it was very hampering and unnecessary.
But that's a pretty important question, because frankly, if you're trying to attract the next generation, being cool is pretty high up on the list.
Yeah.
So
But I think, you know, a lot of scientists now are portrayed in white coats and protective glasses, and I think that's nonsense. I mean, because you don't have to. It's stupid. I mean,
but how important is it to have... I mean, one thing is that young people tend to follow people they perceive as icons or mentors or role models. And so, you know, this goes in many directions. The role models for scientists for young people in science should presumably be attractive in all sorts of different ways, you know, exciting. They're doing cool stuff. They're finding fantastic things. They look more like you than other scientists, so that, for instance, some people would be attracted of the role model by the role model of Tim. Other people would be attracted by the role model of Dr. Narain. They're quite different in some
Yeah.
ways, except inside they're the same.
Well, maybe they're the same. I think scientists are incredibly heterogeneous.
Oh, that's true.
One thing I learned growing up with seeing a lot of laureates in Cambridge, I mean, some of them were amazingly clever. Some of them really weren't.
Yeah.
Or their cleverness lay in what the experiments that
Another
they
question.
did.
Yeah, thank you. Another question.
I am Dr. Giri from the Unicale RCMP IPO. My field is in pharmacology. I just want to ask, the universities are teaching students, or they are mainly running after the accreditation, especially? Accreditation in the sense, most of these universities want to have grades now. In the grades, in the sense, the teachers are forced to publish or perish, something like that. So the universities are also racing to achieve the higher target. And in this process, I believe the standard of education is also going down. In the process, what I'm telling is, we are not creating a curiosity to the students to learn. So there is two aspects in the university. Are we focusing on teaching, or are we focusing on research? Which one is most important for the university to give education or to the research? I just want to ask about this. Thank you.
Well, I mean, I benefit fantastically from wonderful teachers, especially in Cambridge. But some of the teachers were brilliant teachers, and some of the researchers were brilliant teachers, and some of the, you know, there wasn't a very good correlation, I think, actually.
Mm-hmm.
And I think the balance is sort of quite important, actually.
In your own case, is it true to say that your approach to science was improved, your own science, your own experiments, was improved by the fact that you were also teaching?
Yeah, I think so. Very much so, actually.
Mm.
You had to constantly be explaining to
Yeah.
the kids. And, you know, my favorite teaching was teaching in the lab. We used to have third-year undergraduates in the lab, and some of them were very, very talented. And we actually, it was terrible. It led to a ban. You were not allowed to work after 10 o'clock at night.
I'd love to have you, both of you, comment on this.
On teaching and research.
Do you want to go first, Professor Ford?
All right. Okay. In our university, right, teaching is the core.
You speak up.
The core of being a lecturer.
The
Right?
main occupation.
Yes.
Yes.
So you have
What
got-
you're paid to do.
is in a way, yeah. So you got to teach. You have your hours. And then from teaching comes the preparation for exam questions. Come from the vetting, come all these exams and gradings.
Yeah.
That will take a lot of
This
time.
is actually a tremendous enemy of research.
Yes.
in my
and then
experience.
at the same time, we are being asked. We are asked to do research. Not many of us can get the best of both worlds, but we are trying to balance things up, and we are trying to learn from esteemed people
Yeah.
that have reached that level. Now, you mentioned about Cambridge. So how did they teach and at the same time they do research?
Well, actually, it's a good question. So I shared a lab with a guy who was officially a teacher. But he was a lot better than me, actually. He's much cleverer than me. And but I was the one in the lab doing it because I like doing experiments. And we made a very good team. And I observed that Richard, you know, his responsibility as a lecturer really stopped him being very much in the lab. But I was in the lab, and
Yeah.
you know, I was his sort of hands and eyes, if you
Right.
like, and that worked very, very well. And I think that quite often works very, very well. I've noticed that medical research is, you know, a doctor has patients to see.
Yes.
And that means
Yes,
it's
thank
very
you.
hard to do research in a lab because
Right.
actually research in a lab, believe you me, is a full-time business. I mean, it's
Yeah.
sort of 7-day-a-week 52-week-a-year business, right? And, they're long hours too. And that there's not much time left for seeing patients in that. So you need somebody there in the lab who's actually working in the lab. And if you had a good relationship, I mean, Brown and Goldstein is my touchstone here, or Weatherall and Clegg. There are certain famous teams of Nobel laureates or distinguished scientists who have that model. So you need it takes two to tango.
Yeah. Right. Incidentally, you're talking about KPIs here. So I think I can see what we need to do here. Thank you. Yeah.
That's good. Good. Excellent. You solved it. That's it. And then I think last word.
Can I say something about role models? It occurred to me.
You can indeed. And then I want Dr. Lorraine
I
to have
just
the
wanted
last
to
word.
say who my role models were when I was at school. So my first role model was Marie Curie, the physicist. Okay? Because I read the story of radium and it was incredibly inspiring because she was one hell of a woman. I mean, a wonderful scientist. My second hero was Alexander Fleming, who discovered penicillin. I discovered actually he wasn't really the hero of penicillin, but I only discovered that years and years later. And actually it's a very, very good story because the story of penicillin sets the bar for drug discovery very, very high because it really is a wonder drug.
It does work, yeah.
And the amazing thing about it is that it was developed in about 2 years from scratch, actually. Not by Fleming. Fleming was incompetent. He was a wonderful microbiologist, but a useless chemist.
Okay, we'll keep the secret here.
Sorry, is that the end of those two roles?
Well, yeah, so I mean, it's worth reading both, actually, to this day. And I would recommend the study of role models for inspiring the young. I think the stories, the history of science is littered with wonderful examples of interesting things, of how, people saw things and then couldn't understand them and then worked them out. And that's what you need to know. You don't need to know the fancy modern stuff. Go back to the 19th century. I mean, try to understand Maxwell and his equations and Faraday's experiments. These are, for physics, really interesting things.
Dr. Lorraine.
If we can revisit to Tim's statement just now, the earlier one. So you were talking that if you're a doctor and you're trying to do research, I mean, you don't have enough time to do research on your own, right? Then you have to work with someone who's doing research. So in that sense, it means that it's a transdisciplinary collaboration, right? So that is one way to go for you to, involve in research, but at the same time having limited time to do research by yourself. So that is something that we can implement here as well. That's what I'm thinking. But another thing that if I could bring this back to the
Please do.
about the because like for example in Malaysia we are having heavy load on teaching at the same time, and if you are doing great research then only you will be giving less teaching load. It means that you have to do very good research. But for young scientists, right, I mean, we're just starting. So we need the time to do research, but at the same time, we have to deal with the teaching as well. So what I'm trying to bring here is, what do you think? Because we want to try to do research and publish papers. And because we have very limited time, some people may opt to using the AI, for example, ChatGPT, to write the research. I mean, if you do research, that is good. That is actually it's the learning process as well. You're doing research and you get good finding. But at the same time, you have to write your research, and then you use ChatGPT to write your research. What do you think? What, in your opinion, is this a good way of doing it? Will it undermine the hard work that you have done in the lab?
I doubt.
Don't ask him.
But I have to say that, I found writing papers was the worst thing of all. I mean, it never got any easier. It was just always awful because you could never quite find the right words to express it, and the data never looked quite as good as you thought it was in your head, stuff like that.
So, do you think we should use ChatGPT to speed up the process? No.
I mean, it's fine to use ChatGPT to sort of refine things. Maybe I've never used it, so
Me
I've
neither.
hardly played with it. I don't really know. But I just think it's.
Presumably, what you really need is yet more time to bounce ideas off friends and get them to read your drafts. And,
Yeah,
it's just,
I
but
think
that's-
it's all in communication and telling people stuff and sort of working out how best to tell the story. I mean, actually, all these papers are really storytelling. In fact, I see a lot of science as entertainment. Good science
To
can be
use
very
it.
entertaining.
To you, Tim, maybe. I mean, to me as well.
So good. There we are. I think that's our end point. We changed the title, Nurturing the Next Generation of Entertainers. And then we get lots of people applying. It's good.
Yeah.
We solved it again.
And we really need to make it somehow more fun for the kids, right? I mean, and emphasize the playful, inquisitive nature of the thing. It's nothing to do with, you have to go and sort of find out what's known and learn stuff once you've got something going on. And I think that I've got a quote from somewhere from Goethe actually about that. Formal education comes after the kid needs to see why he needs that. I mean, you've got something interesting going on, and then you go and find out what's known.
I have to share this, right? Half a minute?
Yeah.
All right, I have to share this. What we have over here, as mentioned in our opening remarks, is that we came up with the Center for, what do you call that? STEM or TVET.
Yeah.
And what we are doing right now, as a group of us is at school, trying to make science interesting. So I hope this can be something of a new way to get kids, children interested. I like this very much. When I read what they are doing, one of the program is see the unseen. Telling the student to see the unseen. And then the student will say what to see. Then they take a microscope and put something there.
Yeah,
and
of
then,
anything there.
Yes.
Yeah.
So I think hopefully UNICAL is being the leader to this STEM, coming back to science for the children. We're going to school, back to schools. Because
You have to catch them before before they look down the microscope and say, is this going to be in the test?
there's none. We don't talk about tests, we don't talk about that, but we just say something that will bring out the inquisitive mind.
Yeah.
I think what we are talking today is more appropriate to bring this message to the teachers.
Yep. Okay. That's marvelous. Thank you, all three, very much indeed. And thank you also to the audience. Amazing contributions and questions and comments. I think that's all we have time for right now. So I need to hand back to our MC. Thank you.
And we wish you
Thanks,
luck.
Adam.
Thank you very much.
Thank you, our honorable panel members, Sir Tim Han, Professor Dr. Ahmad Fuad, Dr. Nur Ain, and our moderator, Dr. Adam, for such an informative session. I believe all of us have gained valuable insights and knowledge from today's enlightening discussion. As a token of appreciation, we would like to invite Professor Dr. Hushairi bin Abdul Qadir to present souvenir to our main panelist, Sir Tim Han. Please welcome. Thank you. To commemorate this event, we would like to invite all esteemed guests for a group photo on the stage. Please welcome. Right, distinguished guests, Sir Team, if you don't mind, you are now invited for another group photo with the participants. Kita kena jom. Kita tak boleh jom. Thank you. Distinguished guests, ladies and gentlemen, we have come to the end of the session. Once again, on behalf of the organizing committee, we would like to thank our Sir Tim Han, 2001 Nobel Laureate winner for the discovery of cyclines, for being with us today. We would also like to convey our appreciation to distinguished guests and all present for sparing us your precious time. And with that, we would like to invite the distinguished guests and participants. You may proceed to the lobby for the refreshment and the networking session. Till then, wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.